Okay, hi, this is it's lecture 5, AI Essentials for Business. This is the second part. So here, what we're going to do is go through this Jupyter notebook, and I changed the LLM to be Gemini, so that you should be able to get your own Gemini. You'll see in a second. So what are we going to do? Very simple stuff. We are going to talk more about AI agents and try to understand them. There's a couple of things we're going to do. First, we're going to pay attention to the different types of memory. So we'll see, first we'll do an LLM or an agent without any memory. And then we'll show how to add the buffer memory. This is like short-term memory. You can think of it that way. When the computer goes off, then the memory is sort of deleted. You come back on. That's the short-term memory. Then we're going to do the long-term memory. And this, just think of it as saving it to your disk drive. And whether that's in the cloud or locally, it's basically you creating a folder and saving it so that if you turn off your computer, turn it back on, you'll still have it available to you, okay? And then we'll do sort of a long-term RAG, Retrieval Augmented Generation, and we can chat with a PDF. In this case, we're going to do an example with The Portrait of Dorian Gray, which is a book that my daughter's reading. So we'll bring that in and use a RAG. And the idea of a RAG is basically you take a very large document, which consists of sentences and words and paragraphs and so forth, and you are going to break that down into a vectorized space. So think of it as embedding it into some kind of sort of representation where that document now is in a bunch of vectors of numbers or matrices of numbers. And so you can think of it as maybe like a change in measure. So from the words to the number space. But now you hold it in numbers and think of it as a database, so it's really easy to retrieve these things or even search into this vectorized database. If you have your prompt, you're asking a particular question, it will convert it into this vectorized numerical space. It will search this matrix or database, and it will extract and pull out things that are correlated or co-similar. So basically vectors that look similar to it, it'll pull it out and then put it into the prompt, and you can ask it questions. So it's a very standard way to do things here. And then we'll just like kindly touch a little bit into the tools. So remember, the agent can use memory and also tools, and tools will help it create some action. So we'll show you one example of that so you can start getting some intuition. So the first thing we're going to do is we're going to install some of these libraries. I have already installed my API key, and you need to go, it's not an OpenAI key. We're going to use Google, because we tried to use OpenAI, but it asked us for some money. So here we're just going to use your own Google API key. So you need to go get that, consolecloudgoogle.com, find it, and then you're going to actually put right here your API key right here. And then you're going to read it in as an environmental variable, and you're going to be fine. So then you can run the rest of this. I think in class we tried to do it with OpenAI, but they were trying to ask us for like some kind of money or something. This one I think is easy. I haven't paid anything for Google, so I think they give you some credits. So you need to go find your API key. That's the only part that you need to do inside this Jupyter notebook. Okay, now what we're going to do is we're going to use Gemini 2.5. So here from LangChain Google Generative AI, import chat Google Generative AI. And you can see more models on this link. But here we are putting now the LLM. We're instantiating the LLM from this class, chat Google Generative AI. The model name, temperature is 0. If you have a high temperature, then it becomes more creative, and a low temperature is low creativity. Max tokens none, timeout, maximum retries are 2. So let's test this out. So we're going to we're going to use this LLM, and we're going to ask it, tell me a joke. And then whatever it returns, we're going to pull out the contents of that. Okay, here's one for you. Why didn't scientists trust atoms? Because they make up everything. Ha 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 ha. It even put like a little emoji thing in there. That's funny. Okay, so now here's an example where we have an agent, and we're just going to sort of build it block by block, very simple stuff. So from LangChain, prompts, import prompt template. So we'll show you the prompt template just down here. This is just an easy way to bring information into the LLM. You can think of it like when you do your ChatGPT, you're writing in those boxes. That's a prompt, right? But you could add other things into it. And that's basically what's happening with the prompt template. I'll show you in a second here, just below. So here we are creating our LLM once again. And, we're asking it not to hallucinate and then, or be creative. And now here's the prompt. Now, look at this. Prompt template equals prompt template, open parentheses. So you're instantiating an object called prompt template from the class prompt. And inside there's a couple of variables, the input variable input. Notice that you have brackets input. Now look at the template. Answer the following question concisely. This /n just means new line. And then input. Notice this input is in these sort of brackets, right? These curly brackets. So you're going to be able to change that. So this prompt template is going to allow the user to put the input in. You'll see in a second. Then this will go right in here. So answer the following questions concisely. Input, this is your question, and then the answer. So the LLM is smart enough to know that the answer is going to go after answer : okay? So now what we're going to do here is create a chain. And first you're going to go, here's a prompt template, put that in. And then this is a pipe. Then you're going to use that to the LLM, right? So this is sort of a newer, not that new, it's not new anymore, but this is a way to sort of chain these things together. So now in the response, it's going to say chain invoke, right? What is the capital of France? So what is the capital of French? France will be used as the input here into the prompt template here. And it's going to say, answer the following question concisely. Input. Now, it's going to do, what is the capital of France? And that's what it's going to send in this once it fills this prompt template to the LLM. And then it's going to get a response, just like the invoke. And then we're going to print the contents here. So we run all of this, and the capital of France is Paris. Okay, so we printed the response. Very nice. So let's look at it again. So I'm telling you that this first agent that we created doesn't have any memory. It's kind of a boring agent. So I'm going to ask it again, what is the capital of France? And then I'm going to ask it a second interaction in this chain. What language is spoken there? Notice I left this very vague there. So if it had memory, it'd know that we were in France, and it should be able to answer this question. But if it doesn't have memory, which language is spoken there, it's just going to be like, what? So the first question is Paris, and then I put print /n/n to blank lines, and then it responds, you need to specify there. Why? Because it doesn't know that it answered the first question, so it doesn't store the response in its memory. So this is actually very, very interesting. Remember, when you invoke a LLM, it's trying to figure out the next token, right? And then it's given that, then it's figure out the next token, and so forth. But then the question is, did it store what it generated in memory? And in this case, the answer is no. So in this first agent, it does not know that it was previously asked this question, what is the capital of France? Okay. All right. So now let's, with no memory, the AI agent, each question runs independently. The agent doesn't know the reference to France because it has no context. Now, this idea of context is very important. So can we put this context into the prompt so it will remember what the conversation is? And the answer is yes. So now let's add short-term memory. And think of this, as a buffer inside the computer. So it stores the conversation, but you'll see explicitly how this is done. So now we are going to update the code. So we're going to use LangChain again. But with this time, we're going to use conversational buffer memory. And what this is doing is it's storing inside the conversation that it's having. So here's the prompt template. Notice that the input variables are not only input, which was above, but also history. So what we're going to do is the template. This is a friendly conversation between a human and AI. The AI provides lots of details on the context. Good. The current conversation, notice you have these bracket lines, history. So this is an input. You're going to put a string inside here. That will be the previous conversations that you're having. Initially, it'll be nothing, but then it'll start adding the previous conversation. And the human is going to put the question in here. Okay. And then the AI is going to answer. So now what we're doing here is using a prompt template with two input variables. One is the input that you saw before, right? And the other one is the history of the previous conversations, okay? So short-term memory chain, conversation chain, the LLM is here. we're going to use this conversational prompt, okay? And verbose is true, so we can see everything. So now let's put this, run this. Great, you got a green check mark, you're happy. Now let's run this. First interaction is short-term memory, what is the capital of France? That will be response 1. And then notice we're going to call this again, short-term memory chain dot run, which language is spoken there. Now, if it remembers what is the capital of France, then it should be able to answer this question, what language is spoken there, right? So it'll know the context of this question being asked. So when we run that, it says, entering new conversational chain. Prompt after formatting. So this is basically, what is a prompt? The following is a friendly conversation between a human and an AI. The AI provides lots of specific details from its context. Current conversation. Remember, this just started, so there's nothing in here. That current conversation, by the way, is in this history you'll see in a second. Okay, so there's nothing here. The human says, what is the capital of France? That was the question, the input right here. What is the capital of France? Perfect. And then the AI says, okay, finish the chain. Oh, that's a classic question. The capital of France is Paris. And it goes on and on and on because we didn't say, it talks more about Paris, which is great. Now we're asking the second one. Entering the conversational chain. Prompt after formatting. The following is a friendly conversation between an AI and a human and an AI. The AI provides lots of specific details from its context. Okay, so now, what is the capital of France? Oh, that's a classic question. Notice what's happening here. All this stuff is the previous answer to the previous conversation. So it has put into sort of its prompt the previous question and answer, right? So it is holding the history of the conversations it's having, and it's just adding it to the prompt. Now, here's a new question. What language is spoken there? Remember when we did it and it had no memory, it couldn't answer this question, but then notice what happens. That's a great follow-up question. Since Paris is the capital of France, the primary language spoken there is unsurprisingly French, okay? So what's happening here is, we have set up the short-term memory so that it will remember the conversations that it had before in the history. So let's look back from the code here. Notice what's happening in history now. The second time around, it's storing the previous conversation. So that's what is here. Current conversation, right? That's what it had. So when you look down here, you can run through this and sort of read it through. That's exactly what's happening. This is the history after you asked it the first question, okay? Which is the question of the user and the answer from the AI. Okay, great. Now, remember, here's some more, you can try it again, short-term memory. What are 2 famous landmarks there? Once again, I did not specify what there is, right? But it's smart enough to know because notice the current conversation is growing here. One language is spoken there, it's French, and then it says, what are the 2 famous landmarks there? And notice that it's starting to generate these, right? Finish change, picking 2 famous landmarks in Paris is tough because there are so many incredible ones, and so on. So it says Eiffel Tower and Louvre Museum. So that's really nice. However, right, this is in the buffer memory, conversational buffer memory, which stores the previous conversations in the history variable, right? So we saw that. And it injects these past exchanges automatically into the prompt for the context in each subsequent query, okay? So basically that was one way to keep the conversation going. Now, what people do is as the conversations between the human and the AI is responding, it gets longer and longer and longer. At a certain point, what we could do is we could take all of that history and summarize it, right? Which is going to be reducing the size of, remember, maybe these conversations go back 10 times or 100 times, whatever it is. At some point, it's going to get too big. So you can't put that whole thing into the prompt because remember, the prompt windows initially when this industry was developing was, restricted to like 1,000 or I think it was 2,000, and then it got bigger and bigger in terms of how many tokens you could put inside that prompt window. Now it's like 2 million or 1 million. So that constraint has become less and less important. But in the early days, what happened is that we wanted, some kind of memory, short-term memory or whatever it is, buffer memory, and we wanted to remember the conversations we're having. So as the conversations get really long, we would ask it to summarize the conversation. Then we would use that inside the buffer memory. So previously you would say, okay, after, I don't, I'm kind of making this up to 20 conversations back and forth, summarize the history, right? And then it would put that in instead to save up space in the prompt window. But nowadays, because the prompt windows, the number of tokens you can put in there are so great, I mean, it's not as important. Now, this next one that we're going to do here is just showing you sort of this idea of RAG. This is Retrieval Augmented Generation. There's a whole industry in RAG. We don't have time to go through all of that, but the basic idea is, can we store this information onto like a hard drive, your local drive, or in the cloud? And one way to do that is you could store it by the text, but then the retrieval part won't be that fast because you have grep, or you can check, but you can check whatever words by words or these tokens. Or what you can do is you can embed this into a numerical vector space. And now what you could do is whenever you ask a question, you can go into that vector space. You can convert that question, embed that also into the numerical vector space that we learned, I think, this class in the previous, if you look at the PowerPoint video. And so now we're in vector space, and now we're searching a database. It's also in vector space. So now this is very fast, but also we can pull out certain concepts or ideas. Remember the previous word to vec, man minus woman plus, man minus king minus man plus woman equals queen. So there's some context there, and there's some ideas there. So imagine that you're asking a particular question that we'll do in a second about something we can absolutely, understand where in the document these things are, or these ideas of these things, right? So here you will hear RAG, Retrieval Augmented Generation. In this example, we're going to use this Chroma database. This is just a database that is available here. Now, what I want you to see in Google Chrome, Colab, if you open up this document, this folder at the very bottom, if you press it once or twice, you can see that this is kind of, in the cloud, some kind of memory. And what I'm going to do there is I'm going to grab something here in a second. Where is my... I'm trying to grab the... Oh, here it is. I'm grabbing my... this is my daughter's book that she's reading, The Picture of Dorian Gray. And notice it's a very long book. Okay, so, she's a sophomore in high school, 198 pages, like a 200-page book. So there's a lot of pages in this book. And so what I'm going to do is I'm going to take that PDF, I'm going to drop it inside here, okay? And now inside, suppose that we have this, it could be any document you want, or any PDF. It could be a manual of regulations at Johns Hopkins as a doctor, what you had to abide by. But I put her book in here, but you can put anything you want. Now we can have sort of a conversation with this document. And basically what we're going to do is, I think first what do we do? Okay, first we do, we're going to save the conversation, and then we're going to vectorize this document, and then have ask questions in this using the RAG. So so first what we're going to do is we put these things from the library, and notice this Google Generative AI embedding. So that's sort of new here in Chroma. Okay, that's new. So what we're due first is we've done the LLM. We set up the LLM before. We are creating this persistent directory called ChromaDB, and you'll see it created over here once we run this code. And here what we're going to do is use the same conversational prompt, history and input. So this is a conversation that we had before, right? But storing the history. And now what we're going to do is load this embedding model. So just think of this as, you have an LLM, which was loaded here, but these embeddings are taking any type of, document, text, sentences, and put it into a numerical vector space. So think of it like that. It could be a dense vector space, right, versus sparse, so it's going to be putting in a dense vector space. That's really nice because now you can store, large documents. We'll see in the next example how this has been stored into this vectorized database. That's what they call it. Okay, so then initialize or load persistent vector store. So this checks if this exists, all right? Then if it doesn't exist, right? If the path exists, the persistent directory, which is this path here, then you load it, else you create it, or you're going to create a new one. Okay, so that's all this if else is doing. Now here what we're going to do is create the conversational buffer memory with a memory key. Okay, so we are going to have memory. So now we use the conversational chain. LLM is coming in here, conversational prompting coming in here, and then we also have the memory. And here is the function that we're going to call, that we're going to archive, okay, this conversation. So conversation chain run, input the user, response. Now we're going to do vector store dot add text. Here we're going to put this text into this vectorized store, and this vector store persists, saves it. So what happens is, as you're iterating over this conversation, we're going to call this chat and archive function, and it's going to basically start storing this chat. So here's an example. First, let's run this. So the idea here is now you have a chat. Suppose you work at a company and you want to capture the feedback, and every turn you want to save it into some disk drive. So notice what happened here. The Chrome DB has been created. This is where you're going to save this. Remember, this is going to persist. Now we're going to ask it, chat and archive, what is the capital France? And then tell me more about the history and so forth. So as you're interacting with this chatbot this time, what's happening is that as you are doing this, because chat and archive is running this function, it's having this conversation with this conversational chain. The conversational chain has memory, so it's remembering these responses, and every time it responds, it's adding this to the vector store and telling the vector store to save it or persist. So that's basically what's happening here. So you can kind of run that and take a look. Now, how do you read from that? Notice that we created this chroma_db database. Now here's an example where you point to that folder, and now what you're doing is you're saying, hey, let's use this embedding. Let's create this vector store, and then let's pull out the documents from that database that you created of these chats, these different turns of chats. Imagine that you had a really large company, and you had a lot of chatbots on different websites, and you stored this, and you wanted to analyze what's going on. You could absolutely do that. Maybe you hire some Johns Hopkins data scientists or data engineering and say, hey, look, go through all these conversations that we saved, and sort of figure out, is it positive or negative sentiment? How are we doing? What are the topics? What are customers interested in, what they're not interested in? And so they give you access to this data. You go in there, and you can now interact with it with your LLM, and probably do it pretty quick with your Windsurf. So this gives you, I'm not going to go through all of this, but basically this gives you a way to retrieve now, right, from this vectorized data set, which to store these conversations, and you can now ask it a bunch of things. Okay. This one is not as interesting because all I'm asking is, France, Paris, what can you do in, there, right? Now, here is something that might be useful for you. Right here, long-term memory with RAG. So how can you chat with a PDF? And, once again, RAG is Retrieval Augmented Generation. And just to recall, what we're going to do is we're going to take this book, or whatever this could be, a large PDF. It doesn't have to be one. It could be like 400 of them. So you could imagine you go to an organization that has a large legal staff. Maybe it's a finance company or a brokerage company that has to adhere to sort of regulations from the SEC or CFTC or whatever. And there's hundreds of these legal documents or processes and procedures that you have to abide by. You can drop them all in here, and you can vectorize this and then you can have conversations about that without hallucinating, which RAG is very good about pulling out certain pieces of information. And it's getting better and better of sort of being able to interact with that. In the early days of RAG, there was what happens is that you go retrieve something from a document, but it will pull out that exact text from the document. And if you asked it, like, I'm just going to make this up. I know in your homework assignment you had to do earnings report from NVIDIA and Google and Microsoft. And so if you had to ask it questions about NVIDIA, the RAG, Retrieval Augmented Generation, will go into that part of the vector database that only talks about NVIDIA. But if you wanted to compare NVIDIA, to the growth potential, or the pipeline of NVIDIA versus the pipeline of Amazon or Microsoft or whatever, it would have a tough time trying to understand where to pull these things from. So this comparison or more complex analysis, where you guys just crushed it, was a couple of homework assignments ago. You not only looked at two, you looked at three. So what's telling us is that this development is getting, the LLM is getting even better. And I'm pretty sure behind the scenes you have a couple of different RAG types where it allows to pull information from different documents, those earnings reports, and then do some comparison. So so you're stepping in at a time when comparison across documents for certain concepts is pretty darn good. Okay, so let's just back up here. Now let's remember we just have one book here, which is a very simple example. We're going to load and vectorize this PDF document, the picture of Dorian Gray. We need to use Python PDF loader, okay? And then we are going to also use this retrieval question and answer chain. This is combines, this is not OpenAI. We've changed the model here so it could be sort of freely used. But basically your chat, okay? So your chat, we'll use Gemini here, okay? And then remember where this is the prompt template. This will hold the history and so forth and the question, and we query the questions, either questions you're asking, and then we're going to display the result. So let's bring in these necessary libraries, PDF. This is going to help us load the PDF. And then we're going to use some of these original things. We don't really need the OpenAI, but we need the Chroma DB. So here we bring in the libraries, okay? And then we set up the LLM. We're just going to use Chat, Google, Generative AI, Gemini 2.5, right? Which is more the recent version at this particular time, but in a couple of weeks it's going to be Gemini 3, and in a month it'll be 3.5, and in 2 months it'll be 4 or something, or even faster than that. Now, we have dropped our PDF in here. So you can replace whatever the name of the file. This is the path to the file, content, right? And then it's going to be the picture of Dorian Gray, right? So you can actually right-click those buttons and look at the, copy the path, and then put the path in here. I'm showing you just a simple Control-V, so you can see this is the path, and then you can put your quotes around here, right? And then that's basically what you can do. Okay, now here we say Python PDF loader. Put that in there. Load. We call this method. Now that's going to be inside your document. So there you go. You're bringing it in. Okay, so we haven't used the vectorized database yet, but basically what we're doing is we're bringing in this PDF into the memory of the computer. And now what we're going to do is first we are going to call Google Generative AI Embedding, right? So this is the model that we're going to use, just some simple model for embedding. And remember, just recall what embedding is doing. It's going to take this document words and sentences and paragraphs, and it's going to basically create sort of a numerical representation, right? And we're going to store that big numerical sort of matrix of data into this vector store. So you are vectorizing this PDF into a vector store. Vector store is just just think of it, a matrix as a bunch of numbers. Each sort of row represents something in that original document, right? And this embeddings is how do you take the text into these numerical numbers. Remember, we did word to vec, and that was a dense representation of words in sort of that low dimensional space. But it was a dense representation, not sparse, so it wasn't one hot encoded. It was dense, meaning that the information was sort of compressed in 3 or 4 or 5 sort of elements in each one of those places. So you can think of it like that, and now give you sort of an idea. So embeddings, after we're using this particular embedding model, then we use Chroma from documents. We put the document in here. We call the document as this PDF, right? And so we also give it the embedding model it's using, and then we say persist directory Chroma DB PDF. So when I run this right here, you're going to see we're going to have another folder here called Chroma _DB PDF. So notice what happens. We are putting this in the long-term memory because we're storing this to disk, right? So notice that this popped up, Chroma DB PDF. So now if we save this, let's just say this is in the cloud, but if you saved it on your local computer, now you have it saved into the long-term memory. Okay. So now what are we going to do? We're going to use this retrieval question and answer from chain type. Okay. So this is the LLM that we specified up here. Right. This is going to be Gemini 2.5 Flash. Okay. And then the chain type stuff. So this is a little subtle, but what stuffed is doing is you're just going to pull out those things that are similar to the question and put it and stuff it into the prompt. And how do you pull it out? There's a window of how much you want to use, and there's a window of how much overlap you want to have, and that's more of the technical details. But basically, what the idea is that you take your question and you're going to stuff in that prompt something out of this wherever this picture of Dorian Gray, whatever you're talking about, right? You're going to just stuff it into the prompt, and then you're going to send that prompt off to the LLM. Okay, so the retriever is vector store. Vector store, recall, is here, right? And it says as retriever. So this is the one that's going to sort of pull everything together. You have your brain, which is the LLM. You have how you're going to retrieve things. You're going to stuff it into that prompt. Then you're going to send that off to the LLM. And then where are you going to get that information from this vector store? Okay, so retrieval, you're going to augment it into the prompt, and then you're going to generate this thing. Okay, so now that tells you this question and answer chain, this retrieval. Now here's a prompt template. This should look relatively similar. There's two input variables: context. This is going to be the context that you're going to retrieve out of that Dorian Gray. And here's your question. Here's the question. So use the following pieces of context to answer the question at the end. If you don't know the answer, just say you don't know. Don't try to make up the answer. So this is a prompt template that you put in here, right? So I hope you're getting a little bit of intuition on whenever you see these squiggly lines or these squiggly brackets, note that you're going to put something inside there. Okay. And now here's it's written again. Okay, that's fine. But here we're going to use the prompt. We're going to put the prompt inside here. So we specify this. Okay, so this one, it doesn't have the prompt. This one has the prompt. Okay. Now, the query. What is the main topic of this document? So that's what you're going to put inside there. You're going to call the Q&A chain. The query is going to be the question that you're putting in here. And then you're going to get the results. Okay, so what is the main topic of this document? So let's see what it says. Remember, we're using the picture of Dorian Gray. So now it's going and trying to summarize what's happening. So this is pretty good because it sort of pulls that out. Based on the provided text, the document contains excerpts of the picture of Dorian Gray. The snippets discuss various aspects of the story, including a philosophy of life focused on experience, collecting objects as a means of escape, studying senses, and the psychological effects in a dynamic situation involving a character named Dorian and a dead body. So this has your source. This has a summary. You can put any document in there and have those summaries. When you do Google LM, it's kind of doing this, right? It's allowing you to put in a bunch of different documents or even like pointing to different URLs on YouTube, and it's summarizing first, right? And so, this is where it's having the source. This is good for transparency, right? Now, here's a query or question. What's worse than being talked about? Okay. So in the book, we'll see. I mean, if I asked you guys that question, I gave you no context of this book. I would say, what's worse than being talked about? We did this in class, and one student actually got this right. But you'd be like, I don't know. But ideally, you want to ask a question that only exists inside this document in order to prove to yourself that this stuff is actually working. So you'll see that what's worse than being talked about, according to the text, right, which is the Dorian Gray book, the only thing in the world worse than being talked about is not being talked about. So that's, some inside the book somewhere. So I thought that was funny. Anyhow, what you want to do to prove to yourself that this works is bring in a document here that it maybe is really proprietary and doesn't exist on the internet and couldn't be, the LLMs couldn't train off of it. I'm sure the picture of Dorian Gray is already in there, but the point is that you want to ask it something and see if it can retrieve their answer correctly, just so that you can have some confidence that this methodology is working. Okay, now we're moving on to tool search. So I need to actually delete this one because we don't need that because the Q chain is down here. All right, now to tools. So just to recall what's happening here, we're looking at the agent. We just looked at memories. We did short-term memory, did long-term memory, we did RAG, right? And now we're going to talk about the tools. So an agent can go out and use tools. So the tools is something that's available to an agent to use in order to understand the outside environment, right? So one example is suppose we want to search or we want to check the current weather or the current stock prices or anything that the LLM doesn't have. Remember, these LLMs are trained or pre-trained on sort of data that was available at that particular time, and they get pre-trained again, but they're not getting pre-trained like every the next day. So what we want to do is allow for an agent, right, to go out there and search for information and pull in information or even execute sort of things like, write code, execute code. That's what would be an example of a tool. In this example, we're just going to use very simple tools. One is DuckDuckGo search. And, why did we pick that? Well, because I don't want you guys to be spending your time looking for API keys, which you probably could. Trying to keep the API keys as light as possible. So you could use other search engines, but DuckDuckGo seems pretty good enough to make the point on the educational side. So here we set up the LLM. We're also going to use a calculator tool, and this is more historical, meaning that when the first LLMs came out, they weren't very good at math, so we'd have to use something else in order to help them do their mathematics, right? Okay. Now they're pretty darn good at math, so you don't probably, this is already outdated. But anyhow, we just want to show you two different types of tools here. So we're going to pip install quietly, updated, DuckDuckGo search. Okay, we got that in. Now we bring in all the necessary libraries here. And what you're noticing is that you're initialize an agent tools. This is all from LangChain, okay? And I, encourage you to go look at LangChain. They have a lot of really good documentation. Most of it is, I think, all of it is open source, so that's nice. And then some of these things that we've used before. This is Google Generative AI. Notice it was changed. Initially, when I wrote this, it was all using OpenAI, but in class, we noticed that you have to sign up, and I'm trying to keep the burn rate for you guys low. Anyhow, LangChain. Okay, great. A lot of the stuff we've seen. So the first part of this code is just importing these necessary libraries. And then the second part of this code is defining these tools. So there's actually two tools that we're going to use. One is this web search tool. So you can see this is a function search tools, and you can instantiate the search tool from the class DuckDuckGo search run. And then here, what we're going to do is we're going to sort of search tool dot run. So we use the method run this particular query. Query is going to be an input into this function. So you can query it about anything, and it'll run that onto like a DuckDuckGo search, and it will return that. The other one is calculator. So here's an expression, and then we're going to use the evaluate this expression and give it sort of a, this is how you run the calculator, and then you're going to return a string, okay? So these are the two tools. There could be many tools, right? But we're just going to use two just to show you. Here's the LLM. Okay, fine, we initialize that. And then here's the conversational buffer memory. So it's asking you to remember, right? From the first part of this, right? So we did no memory, then we did short-term memory. Now, here is how you load up the tools. Tools equals brackets. So this is a list. So here's the first tool. You need to give it a name, search, makes sense. Function, which is web search. So notice this web search right here. Okay. Now this description is super duper important, right? Because LLMs need lots of text because it's trying to understand text. Useful for when you need to answer questions about current events or the world. Now the next one is calculator, function calculator. Here it is right there. And then the description, useful for when you need to perform mathematical calculations. So this description of the tools, you need to make sure that an LLM can look at the tools, and then it can decide, well, which tool do I need? Do I need to answer questions about current events or the world? Or do I need a tool to use to perform mathematical calculations? Notice it can choose which tool that it wants to use. So you could pack in a bunch of tools, but if you write the descriptions poorly, then it'll get confused. So it needs to know, what is this tool doing or going to do? That's important. Okay. Okay. Now, next, what we're going to do is initialize the agent. We have the tools that it has. It has search and calculator. It has the LLM, right? This is Gemini 2.5. We're going to use this agent type conversational react, reason and act, description. Verbose is true. Memory, it's going to have this memory. Remember, it's buffer memory. So short-term memory, handling parsing errors, true. Okay, so let's run this. Okay, and then we ask it the following question. What is the capital of France? And then we run this. Notice what happened. Entering a new agent executor chain. Thought, do I need to use a tool? No. So it already knows. AI, the capital of France is Paris. Great. Okay, now let's run this. How many people live there? Use actual numbers. Use your calculator tool. Take that number and divide by 100. Please give the answer. Okay, so now this query is a little bit more complicated. Now, if it didn't know that we're in, Paris, it wouldn't know how many people are there, right? But it does have context because we've already put that into the short-term memory, right? The buffer memory. So now the question is can we get this agent, right? It has access to those tools to use the calculator tool and then do some kind of numerical calculation here, right? And then let's see. Okay, so agent input, follow up the query. Let's see the response. So when we run this, so it says entering a new agent executor chain. Do I need to use a tool? Yes. Action, search. Okay. Why is it searching? Action input, population of France, because it doesn't know the current population of France, right? So it's like saying, oh, okay, I need to use a tool. First, do I need to use a tool? Okay, yes, the population of France. Observation. Find out the population, age structure, unemployment rate, real estate prices of Paris, France, capital, and the most populated city. Explore more data and charts in Paris's demographics, culture, and economy. Paris is the capital of France and one of the world's most important attractive cities. The population in 2020 was estimated at 2.4 million. Okay, so it's still using kind of old data. It didn't get the brand new data, but that's okay, and it goes on and on and on because we didn't tell it to be terse or, So thought, do I need to use a tool? Yes. Okay, now it's using another tool. Notice it's asking itself, do I need to use a tool? And then first says yes, and then it says, okay, now what do I need to do? Calculator. Okay, so remember, putting these descriptions of the tools is very important because it's asking, do I need a tool? Yes. Okay, then it says which tool, right? Which tool am I going to use? And so without this description, it wouldn't know. The first one's a search and the other one's a calculator. It may know by name, but it needs, sort of guidance. So it knows stuff, but it doesn't know it that well. Okay, so now it's using the calculator tool. So the first thing it used was the search tool, action search, right? Action input, population of France. The second action was calculator, right? Once it asked, do I need a tool? Yes. Then it put this in here because I'm asking to divide whatever the population by 100. So then it actually calculated correctly, right? And so then it said, could not parse the output. Oh, fine, whatever. Thought, do I need to use a tool? No. Okay. So it says the population of France, the population of Paris is estimated at 2.1 million. Recall that that's like in 2020, so it's not the most recent, but it went out there and searched for that. When you divide that number by 100, the result is 21,000. Okay. So what's happening here, it's actually pretty interesting because in this example, we're seeing the agent, right? Use its short-term memory, first of all, because, the capital of Paris is France. It doesn't need to go and search for that, so it didn't have to use a tool here. Do I need to use a tool? No. Because why did it not need to use a tool? Well, because in all the information that it's ever ingested somewhere in there, it's probably encyclopedia and so forth, and so it knows this stuff. So it doesn't need to use a tool to go out and find something. However, whenever you ask, what is the population there, it knows it's in Paris because of the buffer memory. And then it says, do I need to use a tool? Yes. Okay. What tool am I going to use? Remember, it has to pick. And now it's going to do search because it has to find the population of Paris. That's not a computation. So it's going out there and it's returning this observation. It's going out using this tool to see the environment and it's pulling that information back in. Okay. After that, once it has that information, right, the 2.1 million, it's asking another question. Do I need to use a tool? Calculator, because I told it to use your calculator, right, in this. How many people live there? I didn't tell where there was. It used buffer memory. Use actual numbers. Use your calculator to calculate. And I said, take that number. Remember, I didn't tell it what number, and it's use the actual number. It knows that it's the number of the population of people who live there in Paris, in France, right? And divide by 100. So it's basically doing this action observation, and then it's trying to spit it out to me. And this is right, and this looks pretty right, right? 210,000 and 2.1 million. Okay, so that's 100. And then this is the final answer. Now, what you could do if you wanted to do, make sure that this is the population in 2020, whatever, 4 or whatever, 2025, right? So you could go out back and sort of play around with this to build your intuition. But basically, I think is a really nice example of how an agent can use memory, short-term and long-term, how it can use long-term RAG, how it can talk with a particular document in this Retrieval Augmented Generation, how you get this document here, the picture of Dorian Gray, you vectorize that and you store it in a vector store or a vectorized database, how you interact with that vectorized database, asking a very specific question that's only inside that document. But remember, it doesn't have to be a picture of Dorian Gray. It could be your legal books or whatever it is, your manuals, or it could be an agency's manuals or whatever it is. And then what we did next was we're using tools. So we gave it 2 tools, and one was a search and one was a calculator. And then we asked it sort of the similar question, right? We asked it, what is the capital of France? And then it knew, right? Paris, without using the tool. Then we said, okay, what's the population there? And then it had to search for the population. And even though it didn't use the most recent one, it got the data. And then it said, hey, do I need to use a tool? And the idea is yes, because I asked it to do a simplest computation here on that number that came back from the environment that it found through a web search, right? So this is, I think, a really nice example of, how an agent is using memory. And now we're kind of showing it, examples of tools, but it can use many other tools. And what we can do, and then it's pulling information back from one of the tools from the environment, and then it reasons which tool do I need. Oh, calculator tool now. So you're actually seeing it doing many things, and we're trying to break it down into the small pieces so that everybody can understand what's happening here. So it's more transparent. But remember, I'm just trying to give you guys the intuition here. Okay, with that, I will stop it now.